Hey, good evening. So this is a problem that comes from the problems in your book in section 2.2, number 8. And so we have an ordinary differential equation. It's first order because the highest derivative is a single derivative, and it's non-homogeneous because there is something over here. So what we're going to look at for this one is, well, we need to decide, do we want to use the integrating factor or Euler-Lagrange method? Now, Euler-Lagrange, it's a lot more straightforward when you can pretty quickly see a solution to the homogeneous equation. And this one is it's not quite as obvious. So what I mean by that is, if it was pretty obvious what the solution to this would be, then Euler-Lagrange is a pretty quick way of doing it, but it's not too obvious. So I'm going to go ahead and use the integrating factor method. So a good thing to recall is, with the notation in your book, it would call this one y prime plus p is a function of t times y is equal to some function of t, so f of t. And in this case, p of t, I'm just going to write it out, it's maybe obvious, is just 1 over t. So the integrating factor, mu, I'm going to do this maybe in yellow. So let's find out what that is. So mu of t, this is the helpful value that we're going to use to solve this, is given as e to the integral of p, so 1 over t dt. And recall, we don't care too much if mu is the most general solution. We just need any antiderivative, and so we're not going to worry about an arbitrary constant. So if we look at this, that will give you e to the natural log of t, not caring about any sort of arbitrary constant, so then that just simplifies down to t. So mu of t, to summarize that, is just equal to t. So why is that helpful? Well, that tells us that we can rewrite our original equation right here simply as, maybe we'll do this in a different color, let's say blue, simply as the derivative with respect to t, right? Now what's in here on the left side? Well, here we have y times mu, or as your book calls it, this whole mess, e to the pt. So mu, which is just 1 over t, or I'm sorry, which is just t, excuse me, even simpler, is just t y. And then this is equal to f of t times, which is, excuse me, just 1 over t squared, times your mu, which is just t. So in this case then, what do we see? Well, we have on the right-hand side, that simplifies down just to 1 over t. And so to get ty by itself, get outside of that derivative there, we're just going to integrate both sides here. And so when I integrate it, I have just ty over there, integral of 1 over t dt. Right, so this will give us then, on the right-hand side, the natural log of t, right, plus some constant, and the left side is still ty. So then to solve it for y by itself, scroll down a little bit, maybe do it in green. We end up with y is equal to the natural log of t plus some constant, all divided by t.